All right. So we're doing something here. See, it says that we're live.
Yeah.
I'm waiting to see if we get, yeah, okay. I've got the confirmation here that we are also live on there. Let me.
So surprisingly, it's the first time I'm seeing the message as well that we are live on YouTube.
Oh, interesting.
Generally, it doesn't show me that we are going live on YouTube, other than my phone telling me that there is a new live session that has started.
Oh, okay. Yeah,
But
that
just
makes
that
sense.
Zoom is showing me that too, that we are live on YouTube.
Oh, wow. Fancy. Fancy.
Yeah.
All right. Well, this week we're going to be talking about using XGBoost in R. We missed last week just because it was crazy and we forgot. But the week before that, we talked about setting up a data science environment in R, and the tutorial we were going through didn't really have everything we needed to do any actual analysis. So it was a little bit frustrating. So we wanted to loop back around.
Mhm.
And so we found this other tutorial on using XGBoost in R. And theoretically, this has everything for us to actually complete it inside this tutorial. So we will see, fingers crossed, as to whether or not that works.
Yeah, and from our last foray into XGBoost, we have all the libraries installed, or hopefully all the libraries installed. So we are not going to go through the initial steps of recreating all the libraries. If we come across any library that we haven't installed, we'll just install it at that point.
Yeah, yeah. All right. So we're going to come over here. We know that we're going to work in R. So I went to rc.uab.edu. I'll just go ahead and do that again. rc.uab.edu. And I went to interactive apps. And then I clicked on R Studio server. And I am logged in with my Blazor ID and password. If you're not a student or staff at or faculty at UAB, this might be difficult for you to get a handle of. So you can always install R Studio on your local machine. But this is R Studio on the UAB supercomputer. So we're going to select the most recent version of R. We're only going to do it for an hour. Because if it goes longer than an hour, we need to break this up into 2 weeks. And Express, 4 CPUs and 16 gigabytes of RAM should work. So I'm going to launch that. And while that's launching, I'll show you the tutorial we've got. So we're going to look at this XGBoost R tutorial. This is actually on the XGBoost website. So let me go ahead and put that in the comments of the live stream. I don't know if anybody is watching. It looks like nobody's watching, which is fine. But so there's the link there if anybody needs it. And so we'll start going through XGBoost, and we'll start using R. Let's make sure our R session got scheduled. All right, it's starting up, so it's going to take another little couple of seconds. All right. So just a note up here at the top, in case you're wondering what XGBoost stands for, it stands for Extreme Gradient Boosting. And we've talked about that a couple of other times. So let's scroll down. Okay. So apparently this R package can do parallel processing, which is nice. And you can install it in a few ways. I think we just installed the version in CRAN last time.
Yeah. So the method above that's given, it's for nightly installs with a DRAT and where you give the repos and stuff, or weekly updated version. I would suggest just go with the normal XGBoost because first of all, it's easier to install. And
Yeah.
it is very, very stable, the version that they release onto CRAN.
Yeah.
So if there are any bugs that they might have introduced in the weekly builds, I'm pretty sure they check on it, but it's better to have a stable version when you're doing your production work.
Yeah, absolutely. All right. I'm going to create a new R notebook. Because this should let us show things in line. All right. I think that's the way I remember this working anyway. So execute this chunk. Oh, that's right. So we've got to add a new, we've got to insert a new chunk. That's right. Okay,
There's that insert thing as well.
Oh, insert right here. There you go. Okay, perfect. And then we're going to run. So shift enter runs the selected lines. What runs the chunk? Run the shift command enter runs the chunk. Okay, shift command enter. Oh, let's try this again. All right, loading required package. Okay, so it did it. Perfect. So we do have XGBoost installed, which is good. All right, so now we're going to come down here, and this next piece is going to be loading the data. So you notice here it says data agaricus.train package equals XGBoost. I think this is just saying, hey, I want to load data, and the data has this name, and you can find the data over here in the XGBoost package. And so that should at least theoretically load up. Let's give that a whirl. I feel like some of this is print statements and some of it's
I think they might be on a new line.
oh,
Okay.
These first ones need to be on a new line. Okay, perfect. Okay, so then okay. So all of those are now loaded, and we can see them up here in our data space. Okay, now let's go back to the tutorial. So now we have a training and a testing data set. So they've already split up the data set for us, which is nice.
Yeah, that's what I was about to say, that it looks like that they, in their XGBoost library, the dataset, the example dataset that they have provided, they have already split it into training and testing. I remember if your dataset is not already pre-divided into training and testing, that is something that you will have to do initially before you can run anything that we are going to run after this. In our last video, I think we showed the method of splitting up your data into training and testing. So if you are not working with just the example data set, which most of you won't, you would be working with your own data set, which you would need to split into training and testing. Take a look at that section in our last video, and you'll know how to split your data set.
Yeah. Yeah. So these next couple of things here, we can run these all in one kind of spot, I think, are to give us a little bit more information about our data set. Okay, so let's see if I run this. Oh, it replaces the,
yeah.
So let's just run them one at a time. All right, so this is telling us that we have a list where we have, okay, so there's two vectors or two arrays in this list. We have a matrix of features and a matrix of labels. Okay. And then in our training data, we've got over 6,000 samples. On our testing data, we have 1,000 samples.
Yeah. And the number of, obviously, number of features remain the same on both.
Yeah, so we have 126 features, so that's nice. It's a decent number of features. All right. So now we're gonna go ahead and train XGBoost. Yeah, okay, and this is with some basic training parameters. So let's see how this goes. All right, so we're gonna train XGBoost. We're saying our training data is our training data. Okay, our training label is the label of the training data set. Max depth, so that means we don't want a really complicated model built off of this. So that should help with not overfitting, I would think. But it may also underfit because we have a decent number of features. So we'll have to see. All right, so let's run that. Okay, and we only ran it 2 rounds and our error started to decrease a little bit. Okay.
So right now we have almost 78% accuracy, right? 22% error.
Yeah, I think so, or 2.2.
Oh yeah, 2.2% error.
Yeah.
So 97.8%.
Yeah.
Prediction accuracy.
Yeah. All right. So we can also, let's just make sure we don't miss anything so we don't mess something up later. So we're going to create another one that's a dense version of our model. Okay.
Yeah.
Oh, okay. So this is, I think this is saying, this is the same model. It's just saying that the data type used up here is the XGBoost data type that's embedded within the library. And so it's a more sparse matrix. So we should get the same answer, I think. Yeah. Yeah, so we get the same, because everything else is the same in terms of parameters is what it looks like. It's just the data type that we changed.
Yeah, so this was what they were initially mentioning, that in XGBoost you have different methods of getting your data into XGBoost.
Yeah, here.
Yeah, input type. So there is dense matrix, sparse matrix, data files, and something that XGBoost has of its own, a matrix of its own, that's xgb.d matrix. And obviously that's recommended because it's there.
Yeah. Yeah. So it's more optimized to what XGBoost is looking for.
Yeah, I'm guessing the execution time might be a bit faster on that, since they would have optimized it for their for training their models.
Yeah. All right. So now let's see what this next line that they have here is doing. All right. So this is Dtrain. Okay. So this is, it's 2 lines. They had it grouped together. And this should be, okay. No, that's fine. Let me just spread this out a little bit. There we go. All right, so the first line here is creating, oh, okay, I gotcha. So train data, this is just a sparse matrix. This is a dense matrix. And then once again, this should be the same, we should get the same answer because now we're doing it in XGBoost's data type. Oh, that was not right. maybe. Run current chunk. There we go. Yeah. Okay, so that's nice. I mean, from a data scientist perspective, I don't know that I care a ton about the data types, but if we're being really rigorous, it's nice to know that no matter what data type we're using, we get the same answer.
Yeah, and this might become useful once your table goes really out of hand and it has thousands of features and millions of millions of rows in your data set, where suddenly the time it takes for you to run a model or create a model starts going into days. Then you start seeing advantage of using the D matrix that XGBoost provides.
Yeah. All right, so now, all right, this next piece is the verbose option, which that basically is just if you add one of these flags to the way that you call XGBoost, it's just going to print out more information as to what's going on in the background, depending on which option you give. It looks like verbose equals 1 is the default.
Mm-hmm.
And then verbose equals 2 will give you more information, and verbose equals 0 will run it quietly unless anything goes wrong, most likely. So we can kind of skip over that a little bit. But now let's see. The purpose of the model we have built is to classify new data. Yeah, so this is what I was interested in. So how do we actually use our model to do some predictions? It looks like we do need to run one of these because this is the model we're going to use to do our prediction. So let's run verbose 2. The current chunk. Okay.
Surprisingly, not much, not
Yeah,
much verbosity.
It didn't give us much in the way of verbosity, but that's okay, I guess. All right, so we have our boosted decision tree. Oh, no.
So now you have a video in video.
Yeah, yeah, I'm like, I've got the Zoom helpful bar of things that I can do is like stuck at the top, and I'm trying to like navigate between tabs and it's just right in the wrong place.
Yeah.
All right, so yeah, so this one's not highlighted in red, but this is what we want to run to get our predictions out. So basically it looks like this is saying, make me a new data frame called pred and use this function predict, where the model I'm using is BST and the test data that I have is test $data.
And BST is the BST would be this, right? BST model we created over here in the previous line.
Yes, yeah. Well, and you can use the annotate tools if you want, Ravi.
Yeah, that's what I was trying to do. I thought mouse. I chose mouse.
No, if you're on the mouse one, it doesn't do anything.
Oh, okay.
And so you've got to select like arrow or stamp or spotlight.
Yeah, so this is the BST
this
model
is the
that we created.
Yeah, exactly. All right. So we've got predictions, we've got a model. Now, let's see. Okay. Oh, apparently there's a print head that we can do similar to Python. So let's do that. Okay, so that's going to show us our first few predictions.
Mm-hmm.
And okay, we're predicting whether or not something's 0 or 1. So I guess that's why we're getting something that's close to 0 or close to 1.
Yeah.
All right. Now let's see. So now, All right, these numbers don't look like binary classification. Yeah, that's what we were noticing. So transform the regression into binary. Oh, okay. So you just threshold it. That's what they recommend.
Yeah, so this is very similar to, in generally, if you're doing a prediction model, this is something that you will have to do in a lot of your models. Like I always give the same example, but I'm going to stick with that one again. So like
Sounds good.
if you are trying to find the image of a cat in a picture, it would have some percentage of so your model would be some percentage sure that there is a cat in the picture. It would never be 100% sure that the cat is in picture, or most of the time it wouldn't be 100% sure. It could be like it's 70% sure, it's 80% sure that there is a cat in that picture. Then it's up to you to decide the threshold value at which you would be predicting that whether there is a cat or not. So you can say that if your model is 70% sure that there is a cat in the picture, then just predict that there will be a cat in the picture. 70%, 80% is generally a good idea. I think in this case, 0.5 is a decent idea because I think, isn't this for the poisonous mushroom thing?
Yes. Yeah, this is for a poisonous mushroom data set. So
yeah, so you want to be pretty sure that it's so if you have half 50% doubt that it might it might be poisonous or might not be poisonous, you just don't want to eat that mushroom.
yes. Yeah. Yeah. And so after we do that thresholding and tell it to spit it out as numeric, then we get our classes as zeros and ones. And so yeah, so we can see it. It's not really meaningful at this point because we have no measure of how good we're doing compared to the ground truth. So let's look at our error. And I think that's this line here. So here, let's see that this is a couple of different lines. All right, so our error is going to be the average of the number of times that we are not correct. So basically saying we have a truth statement that says, is my value the same value as my test label? If it is, or sorry, no, is it different? Because if they're the same, then the value of this truth statement is 0. And if they're different, then the average of this, then the value of this truth statement is 1. So if you take the average, then you basically have the average of the whole data set, but the whole data set should be 0 if everything was correct. But if you have a couple of ones in there, then that'll be what tells you what your percentage error is, because that'll be your number of cases. If you have 5 cases and you have 100% or 100 labels, then that'll give you 5% error with this calculation.
Yeah.
So let's run that. All right. So we got like a 2% error. That's not bad.
Yeah, that's not bad at all.
I mean, it's still not as good as I want with poisonous mushrooms, but
yeah. I mean, especially, I'm pretty sure the data set is optimized in some way. I mean, it might have just done all the pre-processing and everything, but from our point of view, we have just thrown the entire data set at a model and not done anything major with it. We are just run XGBoost on it, and just getting 2% error is pretty nice.
Yeah, we haven't done any special fancy things at this point, which is good. All right, so now this is where they're starting to tell us to do some extra fancy things, but in R, in any case, to get some of the extra fancy functionality, we have to have our data in the XGBoost data matrix format. So let's run that. So now we've got our training and testing data in the XGBoost format. And here we go. Watch list. Okay. Interesting. I don't know what the watch list does in
Yeah, I'm
in R.
not sure. So it gives that it is a list of xgb.d matrix.
Mm-hmm.
And
yeah, it's a list of the two data sets. Oh, that must be another functionality of the XGBoost. So let's see what happens when we run this. And let's make verbose equals 2.
yeah.
Oh, what did I do? Oh, oh,
The wrong.
yeah, they're Windows quotes. Okay. Okay, so this is giving our training and our testing error over both of them.
Oh,
Okay, so I guess that's what the watch list is for. It's just saying, try out the model on both of these data sets.
yeah.
Okay. So now we've got the same error that we did above. And we have XGBoost computing that automatically for us this time around, which is nice.
Yeah.
All right, so now we have, let's see, all the learnings we have performed were based on boosting trees. XGBoost implements a second algorithm based on linear boosting. The only difference with the previous command is booster equals GB linear and removing the ETA parameter, okay? So let's copy that. That, and let's run it. Okay. So, wow, okay, so it looks like our error went down quite a bit.
Yeah. Actually, way less.
Yeah, because instead of 2%, it's 0.2%.
Yeah. Now it seems like at a place where we can trust it with poisonous mushrooms.
Yeah. All right, so this next part is about saving and loading the models. I'll leave that to you guys to kind of check out, but certainly if you're doing work with this, it makes a lot of sense to both save your code in something like GitLab, but then also to save your model file after you've trained successfully, especially into a file so you can read it back in and use it for testing on other data sets as well.
Yeah, it could also be used for different applications. We should have a video just on that. I don't think we have any video just for saving a model and reusing that model somewhere.
No, we did one. We did one on checkpointing at some point in Python.
Yeah, I mean, most of the features are the same from checkpointing, because over there also you are just saving the model at every checkpoint that comes in, and but we should just be like, you save the model here, and in the next program you can use it. I think that might be useful for people, because that was a concept I was always when I first started with data science, I was always thinking, because most of the tutorials online, they will tell you that in a single Jupyter notebook, how you create your models, how you run your models. But then you think about that when
every
you start
time you do
that,
it,
how does Google use it on their website? If they're just training and testing it in a single Jupyter notebook, how do they use it in their applications?
Yeah,
and
that's a good point.
Yeah.
No, that's a good point, because if you don't save out your model, then you have to rerun your whole Jupyter notebook or R notebook every single time. But yeah, in production, you're going to have to save out the model and put it in some other format. So that's good. We'll have to look up something like that for later for sure.
Yeah. Yeah, we should have a video soon. And I don't know when, but maybe in the next couple of months or so, we can have one video just on that.
Yeah. Yeah, I think that would be good. All right, so this next piece here is interesting, and this is the part we couldn't get to work on the last one.
Oh yeah,
Is the feature importance. Oh, well, that's a cool graph.
I know.
All right, so we get a table of our feature importance. So it looks like the spore print color is really important.
Yeah.
And whether or not there are grooves. Okay, so let's see. If it's green, if it's got grooves, and if it's pungent or creosote.
I don't know what that means.
I don't know what that means either. But if it's got a conical cap shape. All right, cool. And then these are all the things that are negatively correlated with that, I guess.
That is super nice. So I always find the feature importance to be a pretty decent part,
yeah.
decent portion of the entire module. I don't know. I mean, in research, it might be really, really useful. So like if you are doing some research on those poisonous mushrooms, you can look at those features, which are very, very important. And you can try to find the link between that feature and the poison value of mushroom. Why is that the case?
Yeah, no, absolutely. I really like this graph. That's a really fun.
I agree.
Fun graph.
It's awesome. It's like a mushroom.
Yeah, it is like a mushroom. And it's kind of nice that they didn't that they don't actually have the visualizations in the tutorial. So then we get to see them for the first time when we make them.
Yes.
That's kind of fun too. All right. So let's see, I'm going to come here. So we can also, in addition to the feature importance, we can visualize the trees. So basically we can visualize the actual model that we created in XGBoost as well. Let's see how this works. Diagrammer package is required. Okay.
We can try to install that diagram RNC.
Let's see if I can do it through packages here. I don't know if this was a good choice. All right, I'll just insert another chunk of code here. Install the packages.
Does tab do auto completion in our notebook?
It might, but I might have broken my R notebook. I don't know. Let's find out. Diagram R. I need that in quotes, don't I? Oh, here we go. I finally loaded up. Okay, so I need diagram R. All right, let's install that.
All right, that's not a lot of dependencies.
No, and this is using R's package installer directly. So I didn't even really have to type what I was typing in on the command line. I just was not optimistic about it. I think we can come over here and type require. Oh, I'm causing trouble here. Yeah, require. Why is it smashing all sorts of numbers on my keyboard here? Diagram R. I think that's what we're going to have installed. All right, so that's installing. Let's see if there's anything else. Okay, so again, we can
Save your model.
save things. And then let's see, I think this is basically saying after we did that with the boosting, then our error over our testing data set is 0, is what it looks like. But let's see. Oh, that's odd. Okay, so it's still installing.
Hit one of the arrow keys. Yeah, over here. Okay, so it's still responsive. So it's,
Yeah.
I just wanted to check if it has gone unresponsive completely.
Yeah, let's just, in the interest of time, if I just search, let's make sure nobody's talking to us. Okay. Let's see, XGBoost 3. Oh, I probably have to type in visualization. Let's see what they look like. All right, so it'll look something like this. That basically will tell you, all right, so here's a feature. So feature 1, if it's less than this number, go left. If it's more than that number, go right. And then basically tell you how the model's built. So you could actually do this on a spreadsheet or compute what the model is doing by hand if you wanted to. That's also really handy for, okay, here we go. It's also really handy for determining if your model is doing things that make sense. Because if it's not, here we go, let's see. This function can only be used with tree models. I thought I had
Non-tree model detected.
Huh. All right, let's see, what did I miss?
Model equal to BST.
Oh, okay, so wait, did I do the dump? I did the dump. I think there must be something else here that I missed. No.
I don't know. Is this an output? Because we didn't get this output too.
No. Let me just run that one line.
Oh, we did. We get the.
Yeah. Weird. Maybe there was one, probably there was another version of this model that didn't run upstream. Let's see, BST.
All right.
This one right here. It's probably the one that I did not run. So let's, because I think that was above the importance one. Let's run that chunk. Oh, Dtrain 2. Okay, so this is basically saying if I had another data set, let's see, to load it in. Oh, okay, so this is just loading in my training data matrix as a different one. All right, apparently we needed to go through this part in order to not mess up our model here. So we're going to save out our data and then load it back in as
Dtrain 2.
Dtrain 2. And then now if we run this, That should work. All right, and then now, looks like it stripped it of our
Yeah,
feature
the cool.
names, which is kind of frustrating. Hey, there we go. Yeah, so this is the visualization of our model. So if you knew what feature this one was, then you could kind of follow this decision tree up or down to figure out which class it would end up in, depending on what its values were. Yeah, that's pretty decent, aside from the fact that this stripped out our feature names.
Yeah, I actually like the previous version.
Yeah, I like the feature importance that still had the feature names in it, but yeah. Well, in any case, I'm happy we successfully made it through an XGBoost tutorial in R.
Yeah.
And so if you're wanting to use XGBoost, hopefully this will get you started if you're an R lover. And yeah, so that's that. And we will keep on doing this every week. I know the semester is about to end. Or at least that's what people have started telling us. So
yeah. And I think it's Friday today.
it is. I'm fairly certain it's Friday today. I think you're right. I think you're right about that.
So people
yeah.
who are taking the data science club sessions, you can come to our office hours. William already posted an announcement in the data science club on our Canvas board, and you can come to our office hours, just show us what you have been working on. We can talk about any questions you might have or problems you might have faced while going through any of our videos. And yeah, feel free to reach out.
Yep. Absolutely. Well, sounds good. Well, until next time, we'll talk to you guys later.